Hi guys, today we're going to be looking at graphs that are part of statistics. Hopefully a lot of the graphs that we talk about today you're familiar with, but we're going to be looking at when each one of these is used, and we're also going to be talking about when you look at the shape of them, what shape they make up. So we're going to start with a couple of graphs that I'm pretty sure you guys are very familiar with. First one we see here is a line graph. A line graph is always used to show trends over time. That's your key part right there. If you're reading about how somebody wants to track data and show trends over a period of time, we are talking about a line graph. Hopefully when I say line graph, you know what I'm talking about. Typically your x-axis is your time and your y-axis is your amount, and you plot your points and then connect them with straight lines. So these are up and down straight lines, very jagged looking. The next kind of graph, a bar graph. I'm hoping you guys are very familiar with this as well. Bar graphs are used when data is categorical. Categorical data happens when you ask somebody a question like, what's your favorite color? You're going to gather the data, and of course when you're making your bar graph, the colors will be down below, and how many people like each color is going to be on the y-axis. What's important to know about a bar graph is that the bars never touch. That's important because when bars touch, it means that there's overlap. And there is definitely no overlap when it comes to categories. And of course, a bar graph shows the actual number of people who chose that category. The reason that piece is important is because a circle graph very much shows the same data as a bar graph. Circle graph is also used when the data is categorical. You can ask somebody again their favorite color. You can make a bar graph out of it that shows how many people chose that color, or you can make a circle graph out of it that shows the percentage of people who chose that color. So these first three I'm hoping you're familiar with, and these are usually some of the easiest ones to decide to use in certain situations. So let's take a look at some more. These I'm hoping you've at least heard of, but maybe you're not as familiar with them. Histograms. These are used when you have very, very large quantities of numerical data. And the key word there is numerical. You collect data and there's so much of it that you don't want to have to write out every single value. With a histogram, what we typically do is we then take that data and we group it into ranges. If you're talking about, let's say you gave a test, a final exam at college to 1,000 students. Well, you might group the data by, 0 to 10%, 10 to 20, 20 to 30. What's important to know about these ranges is when you're grouping the people into ranges, the ranges have to be the same size. So if you group them by 10%, got to be 10% the whole time. You can't just say A, B, C, D, F. What's also important to understand is this right here. Histograms do not show every data value. Once you group them, all you know is that between 70 and 80%, there were, let's say, 100 data values. You don't know what exactly those 100 data values are, but you know there was 100 of them. So that's the downfall with a histogram, is you will not know every data value if you're given a histogram to work with. Stem and leaf, I'm pretty sure you guys have seen one of these before. Stem and leaf is when you have one number on the left of a straight line and then a bunch of numbers listed in order on the right of a straight line. These are used again with numerical data, and they can be used with a wide range of data. However, we don't use them with as large of quantities because a stem and leaf plot, you have to be willing to write out every number in the group. These are grouped because you're saying, if it's a test, you're doing the 10s and the 20s and the 30s and the 40s and the 50s. So these are still groups like a histogram. However, unlike a histogram, stem and leaf, you do know every data value. A dot plot. These are used also with numerical data. However, these are with a very small range. The reason I say this is when you make a dot plot, you're using a number line, and every number has to be listed on the number line. If your lowest number is 5 and your highest number is 15, you have to put on that number line 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. You have to use every number in between. And once you make that number line with those numbers along the bottom, you use either a dot or an X to go up to show how many of each item there is. A box and whisker is our last one. This one is used when you want to display the median. If you hear anything talk about, I want to display the median or the highest and lowest values, that's what a box and whisker plot is. Hopefully you remember what these look like. These are a box. They have a line down the middle of the box, and they have the whiskers out to each side. We looked at one of those yesterday in class. So now that we've learned about the 7 different types of graphs, we're going to look at some situations that involve a few important words that kind of tell you what kind of graph to use. So let's look at example 1. Monica records the average temperature for each day in July. She wants to display the data to show a trend over time. So the key word was trend over time. And of course, trend over time, you're talking about a line graph. The results of a marathon are recorded by age groups of 5. Most people stop right there. They hear age groups of 5 and they assume it's a histogram because you're grouping them by 5s. However, if we keep reading, it says the foundation sponsoring the marathon wants to create a display to show the average finishing time for each age group. So what's happening is they're taking all the people, let's say between 20 and 24, and they're averaging all their time. So that data group only has one value. And then 25 to 29, they're finding the average, and that data group only has one value. When a group only has one data value, it's not a histogram. When you're just finding the average, that actually ends up being a bar graph. Again, the average finishing time there is the important part. We're talking about a bar graph. So let's keep going. Again, feel free to pause. Why don't you guys pause the video for a moment? Why don't you try examples 3 and 4? Hit pause. As soon as you unpause it, you'll hear me explaining again. So a bookstore owner, we're looking at example 3. A bookstore owner records the number of books that are sold each day for 1 month. Again, people read that, they stop right there, they think, ooh, 1 month, that's time, it's a line graph. However, if we keep reading, she wants to create a display to show how the data clusters around the median. There's your key phrase. Data clusters around the median. That automatically means median, box and whisker. Example 4, a college professor gives the same final exam to 500 of his students. That right there should be a big clue. 500 data values is a lot of data. He wants to organize it in 10% increments. So 2 important things there. 500 of his students, 10% increments. So you're taking 500 data values and breaking them into 10% ranges or groups. That right there is your histogram. So hopefully you got both of those right on your own. Again, pause the video, read through number 5, see what you think, unpause it and you'll hear me explain the answer. Mr. Patel recorded the number of seconds it took each of his students to run through an obstacle course. The data is shown in the table. So as you can see, we have 27 all the way up to 56. But we have a very manageable 24 numbers here. So the minute you hear 24 numbers, histogram is out the window. You're going to use something that writes out every number. He wants to create a display of the data to present to his class. So if histogram is gone, that really leaves us with stem and leaf and box plot. So when you think, stem and leaf and dot plot. When you look at those two, stem and leaf allows a wider range. Dot plot does not. I don't think you want to write out every number between 27 and 56. So since stem and leaf is the one that still allows a wide range, we're looking at a range of 29. As you can see, 56 minus 27 leaves us with a range of 29. We're going to go with a stem and leaf plot. So hopefully you had that one correct. These are the kinds of questions you're going to see on half of your homework. Very basic questions. What kind of graph is appropriate? Next thing we're looking at are the shapes of distributions. The UC loves to give you a picture and say, describe the shape. We have a total of 6 shapes we're going to talk about. You can see the first 3 here. Skewed right. This is when all of your high bars are over here on the left side, and you have a tail or your low bars over here on the right. So if your graph goes high on the left and then slopes down to a very low right, this is considered skewed right. So since the tail is on the right, it is skewed right. Skewed left, just the opposite. You have your high bars over here on the right, and you have your tail that slopes down to the left. So if your tail is on the left, it's skewed left. Bell-shaped. For anybody who's familiar with a bell, bells are high in the middle and low on the outside. That's what we're talking about here. Your highest bars are here in the middle area. Your low bars are over here on the outside. Usually, they look pretty much the same on both sides. So a lot of times, you will see bell-shaped and symmetrical used interchangeably. So if you're given a picture like this on the EOC and bell-shaped is not there but symmetrical is, this is definitely symmetrical. As you can see, it doesn't have to be exactly perfect, but it's pretty well balanced on both sides. Let's look at the next three. U-shaped, pretty much self-explanatory. Your high bars are here on the outside. As you can see, there's actually 3 different examples in this picture. There's blue bars, green bars, and red bars. All 3 of these are U-shaped. Your lows are in the middle. If you look at the blue and the green, they're very high in the outside and very low in the middle. If you look at the red, it's still U-shaped, as you can see, but it's not very deep U. Doesn't matter how deep it is, as long as it's U-shaped. High on the outside, low in the middle. You can draw a U in the middle of the graph. Bimodal. A lot of people confuse bimodal with U-shaped because they look at this and they do see a U shape going on between these 2 bars. However, bimodal is different. If you notice on this picture, there are low bars on the outside. When you have a graph that has 2 bars that are exactly the same height, as you can see, the 2 highest bars are exactly the same height, that means that there are 2 modes, which is why we call it bimodal. And as it says here, those 2 highest bars can be anywhere on the graph. Our last one is uniform. Think about this. At a school where people wear uniforms, they all look the same. A uniform graph looks pretty much the same all the way across. This is an example of a uniform graph. If you notice, you see the red line that they drew across it. Notice not every bar is perfectly the same, but most of them are around the same height. That's the idea. Mostly the same height all the way across. So we have a couple of very, very quick examples that talk about these. So pause the video. I would actually like you to try all of the examples on your own to see if you can figure out what they look like, and then go ahead and unpause and see if you got them all right. All right, so at this point you should be done with all of your examples. Let's take a look at example 6. You see a graph here. This is an example of a stem and leaf graph. Most important thing about a stem and leaf is you need to turn your head sideways and actually look as though this is the top of the graph. So as you can see, I drew in this smooth little double bump. If you notice, both of these are high bars, and there's 2 of them. There's lows in between all of them. So because there's 2 highest bars, but there's lows mixed in, this is not a U shape. This is your example of bimodal. Hopefully you got that one right. Let's look at example 7. This one, again, if I use my pen, as you can see, I drew it high, and then it started tapering off and going low as you went to the right. Anytime you're low to the right and high on the left, it is considered skewed right. Is this the one that maybe you guys get stuck on? Because you look at this and you don't really see a typical graph. This isn't skewed. This doesn't really look like any of the ones we described. But if you remember when we talked about bell-shaped, there was that word symmetrical that went along with it. If you look at the middle of this graph right here, If you look at both sides, they both look pretty balanced. Are they perfect? No. This box is just a little skinnier than this side. However, they are pretty balanced. The whisker parts, pretty well balanced. So because this is the same on both sides, we call this symmetrical. So hopefully the 3 examples there that you had to do were pretty self-explanatory. So at this point, if you would like to start working on your homework, you're more than welcome to. This should be a pretty easy assignment for you. You'll have time to work in class, and we'll make sure that we go over answers in class as well. This will be one of those assignments you get done in class. Talk to you guys later. See you in class.